the kind of atomic power we use today is based on fission, that is the splitting of heavy nuclei. When and where did fission first take place and who did it? Well, it happened first in Berlin in 1938, December 1938, and two physicists, Otto Hahn and Fritz Strassmann, at the Kaiser Wilhelm Institute, did an experiment where they bombarded uranium samples with slow neutrons. There was no point in bombarding the uranium with protons because, as I've already explained, protons have a positive charge and they would be deflected away from the nucleus. They wouldn't penetrate the nucleus. But of course a neutron carrying no charge will sail straight into the nucleus, and they carried out this experiment where they bombarded uranium for a period of time with slow neutrons, and then they stopped the experiment and analysed the target. I think they were hoping to find some transuranium heavier nuclei, but they found traces of the element barium, element number 56, and this was very puzzling. They couldn't understand the meaning of the result and what had happened, and Hahn decided to send his results to a former colleague of his, an Austrian physicist, a woman called Lisa Meitner, who was then living in Sweden. She'd worked at the Kaiser Wilhelm Institute, but had left Germany when Hitler came to power because I think she had some Jewish family connection. She had a nephew, Otto Frisch, also Austrian. He was her nephew. He had also fled Germany when Hitler came to power, and they'd arranged to spend Christmas together in Sweden, and they spent Christmas Eve in 1938 looking at Hahn and Strassmann's results. They discovered, or the conclusion that they came to at the end of a very extensive discussion, was that Hahn and Strassmann had actually split the uranium nucleus. They'd split uranium-92, element number 92, into barium and krypton. Barium element number 56, krypton element number 36. 56 plus 36 equals 92. So the uranium nucleus had split into two other nuclei, one of which was slightly bigger than the other, and it had also emitted, so they thought, 2 or 3 fast neutrons. Now, if you calculate the masses of the two resultant nuclei and add in an allowance for a few neutrons, the mass is less than the original mass of the uranium-238-235 mixture. Where does the mass go to? Well, it's this mass which is converted into energy according to Einstein's equation. And they sat and thought about this, and they calculated that each one nucleus fissioned, it was Frisch who gave the word fission to this splitting process, each time a nucleus underwent fission, 200 million electron volts of energy would be produced, and that figure is not disputed today. Their conclusions were correct. They wrote a paper to Nature, and it stunned the world in early 1939 when everybody read about this. People had talked about splitting the atom. They realised that it could well be a source of energy, but they hadn't realised just how easy it would be. All you have to do is to fire a slow neutron into the nucleus and it will split. Now, Meitner and Frisch realised that Hahn and Strassmann had found only a very small trace of barium. The reason for that is that Hahn and Strassmann's sample, raw uranium oxide, probably from a mine in Czechoslovakia, would be 99.3% uranium-238, the non-fissile type, and only 0.7% would be the 235 fissile material. So therefore, in their target, only a tiny fraction of the uranium would have fissioned, and therefore only a very small amount of barium would be produced. So when only 7 atoms in 1,000 are the fissile variety, you're not going to get a lot of fissioning out of that material. Now, the consequence of this discovery was that people immediately saw that there were 2 possibilities for the future. Possibilities, nobody knew how to do it. The first possibility is if you can bombard uranium, cause fission, and then use one of the resulting neutrons from the fission to hit a second nucleus and cause that to split and emit further neutrons, and use one of those neutrons to cause a further fission. If you do that, you get a controlled chain reaction, one splitting, one splitting, one splitting, one splitting. That could be the basis of a nuclear power plant, in principle. The second possibility is, since each splitting nucleus emits 2 or 3, usually 2 or 3 neutrons, the second possibility is that if you split the first nucleus and then get 2 of those nuclei to hit 2 further nuclei, producing 4 neutrons, get those 4 neutrons to hit 4 nuclei to produce 8 neutrons, 2, 4, 8, 16, 32, 64, 128, and so on, you can get an uncontrolled chain reaction, in other words, an explosion and the liberation in a short period of time of a huge amount of power, the basis, if you like, of the atomic bomb. Both of those possibilities were perceived. Now, the timing of this discussion, the timing of this discovery had a big influence on the development of atomic power. Berlin was the capital of Hitler's Germany, and in the end of 1938, most people could see there was a high possibility of a new European war in the near future. And the fear was that the Nazis would develop a nuclear weapon. So the timing more or less guaranteed that the first exploitation of atomic energy would be for military purposes and not peaceful purposes. And this is in fact what happened. So that's the story, if you like, of the discovery of nuclear fission. The term for the splitting of a heavy nucleus into 2. The name was coined by Otto Frisch, and when this splitting occurs, there is a loss in mass which is converted into energy. It's that that's the source of atomic power. It's that that's the source of the devastation produced by an atomic bomb. The energy appears as heat and light in a nuclear weapon, and vast amounts of power can be produced at that stage. So that's the story of the discovery of fission.